Hi and welcome to the last lesson on Boolean topic. This one is Boolean Algebra. As usual, a quick starter to begin with. Which two of these do not simplify to A? Well, if we have a go at them, these are all straight Boolean expressions, but you're not expected to remember them, you're expected to figure them out. So this is something or 1. The rule for an OR is that anything being a 1 makes it a 1. We've already got a 1 here, so it doesn't matter what that is. So that's going to simplify to 1. So not that. That doesn't simplify to A. A and 1. Well, if we've got a 1 going into an AND, that doesn't make it a 1. This also has to be a 1. So this one does simplify to A. A or 0. Well, if you've got a 0 going into an OR, if the other one is a 1, then that's still a 1 overall. So it depends what A is. So that one will simplify to A. That does simplify to A. A and 0. Well, if a 0 goes into an AND, there's no way for that to ever be a 1 because both sides have to be a 1. So that one is going to simplify to 0. So that's not simplifying to A. And these two, if they're both 1s, that'll be a 1 overall. So that'll be A. And there, if they're both 1s, that'll be 1 overall. So that one's A. So the only two that don't simplify to A are this one and this one. Well done if you got that. So last lesson, we identified 9 Boolean identities, which can be used to simplify a Boolean expression without using a truth table. I did talk about the difficulty memorizing them, but all of them are ones you should be able to figure out from first principles. The problem is, sometimes we'll get an expression that can be simplified, but doesn't appear to use any of the identities. For example, look at this one here. We can't use any identities on that, but if we use a truth table, we can simplify it. Do a quick truth table. So A and B. If you want to pause this and do the truth table before me, go for it. 1, 1, 1, 0, 0, 1, 0, 0. Then we'll do these bit by bit. So do the A bar first of all, which will just be the opposite of A. So 0, 0, 1, 1. Then we'll do not A or B, which will be this one and this one, as long as it's got a 1, which is that one. There's no 1 there, there is 1 there, is 1 there. Then finally, it's A and not A or B. And what we're looking for here is this A and this not A or B. We're looking for both of them are 1. And that's the only one where both of them are a 1. So this here is the truth table. And hopefully the more eagle-eyed amongst you should spot that this is only a 1 when both A and B are. So that's an AND. So in other words, we can tell from this truth table that A and, that's strange, well, A and not A or B simplifies to A and B. Now we can tell that from a truth table. How could we do it straight from the Boolean expression? Because none of the identities apply to any part of that yet. Well, there's one more trick we've got up our sleeve that we can do to make this simplification work. We can use algebra the same way that we use algebra in maths. Now hopefully in maths you've all seen this, expanding a bracket. The idea is that you've got something like A B plus C. We can take this A and we can move it in there and in there to make it AB plus AC. Usually people are perfectly happy with the maths version of that. Well, the same trick works with Boolean expressions. They look a bit more complicated, but it's the same idea. So if we have, and I'll just write this one out again, if we've got A and B or C, we do the same trick. I'll just change the pen colour, make this a little clearer. I take what's on the outside, which is the A and its operator, must remember that, and that goes inside and applies to the B and applies to the C. So we get A and, because the operator goes in there, B, then this operator just stays there, A and, because the A and applies to C as well, A and C. So that's the way we can simplify it. So if we then look at the one we had before, we can now simplify it without having to draw a truth table. We expand the brackets, we take this and apply it to there and to there to get us this, and now we can start using identities. Here's an identity we should be able to recognise. A and not A is 0, because it's not possible for both of them to be 1, so that's a 0. Then 0 or anything is just anything. So this simplifies to that. Now, where this is a little more complicated is that in regular maths, you can only do that when the value outside is being multiplied. You can multiply into brackets. You can't add into a bracket. However, with Boolean, even if the symbol is a plus, or works exactly the same way, we can still take this A or on the outside and expand the bracket with it. So if I've got, let's write it down here, so if I've got A or B and C, I can still look at the outside, and I'll change the pen colour back. I can still look at the outside here, take the operator with it, and apply it to both the values inside the bracket. Works exactly the same way. So we can have A or B, because that's the A or being applied to the B, and because that stays there, the A or getting applied to the C. That works. You can't do that in normal maths with pluses and timesers, but you can in Boolean with ors and ands. Sometimes the questions will expect you to spot that pattern in reverse. They'll give you an already expanded bracket and expect you to factorize it, to take the common value out again. So let's look at this one. You're told to simplify A and B or A and not B. You're not expected to do double bracket expansions that you might have seen in maths. Not a part of Boolean. What we should spot though is there's an A and here. There's also one here. So that looks like that's already been expanded into those brackets. So let's take it back out again. Let's take that A and out. And what's left inside? Well, there's this B. There's the or. And there's this B. This not B. So now we've got back where we were. And now we can apply a Boolean identity. Because B or not B is a 1, because there's no way for both of them to be 0. One of those has to be a 1, therefore an or will make it a 1. So that will then become A and 1, and A and 1, as we know from the identity, simplifies to A, which is explained down here. So sometimes you'll expand the brackets, sometimes you'll be given already expanded brackets, and you'll take the value back out of it. But that's the only bit I'm going through for this lesson, because it's a complicated one. I'll need you to practice it a bit. The general technique for simplifying Boolean expressions is to first of all look and say, can I apply any identities? If you can, great, do that. If you can't, then you probably need to do an expansion or a factorization. So you look for that. You look for, is there a possibility to multiply something into the brackets? Or is there a common value that I can take back out of the brackets? If there is, do that and then start again. Look again. Now, can I apply any identities? And you almost certainly will be able to. So there's a couple I'd like you to have a quick go at. You do those to yourself. Pause the video and I'll go through it in a second. Okay. So let's do this first one. This is a multiplying into the bracket, so I'm going to take this and apply it to that one and to that one. So the not A or gets applied to A, that stays the same, and that not A or gets applied to B. So that's what it expands to. Now I have a look. Can I apply an identity? Yes, I can. I can apply one here. So that's going to be 1. So it's 1 and not A or B. 1 and anything is just anything. So that will be not A or B. This side, it's already expanded, so we're looking for what's common to them both. Now this is an A and this is a not A, so that can't come out, but we've got an and B, and doesn't matter if you swapped it round, A and B equals B and A, there's no difference, so we can take the B and out. So that becomes B and we see what's left. Well, there's an A left, an OR, and an A bar. So now, any identities? Yes, that one there, just like over here, simplifies to 1, so it's B over 1. Anything, sorry, and 1. Anything anded with 1 is just itself. So that simplifies to B. Now, if you're struggling with this, that's kind of normal. This is as tough as Boolean stuff gets. If you can get your head around this, then you're laughing. But don't worry if this is where I've lost you. If you followed it up to this point and are finally struggling with this, that's normal. That's about right. This is the most difficult part of this. If, on the other hand, you've got your head around it, you're doing really well with this, and this is as much as we're doing with it. So this is the end of the Boolean topic. There's, as usual, there's a quiz on the VLE I'd like you all to complete. Once you've done that, you need to spend the rest of the week doing a little bit of revision on it, because for our last lesson next week, I'm going to give you an end of unit task, an end of unit quiz on the whole of the Boolean topic. Okay, thank you very much. I'll see you next week.